Hi, everybody. Thank you for joining us. I'm Niall Buchanan with Broadcom. I'd like to welcome you to our session today on the topic of what's new in Db2 Tools from Broadcom. A lot of new and exciting advancements in this area, and the focus of our session today is the inside scoop on what's new. Don't forget your session evaluation and the charity donation. If you have any questions during the webcast, please feel free to submit those through the chat window, and we'll be having a live Q&A at the end of the session. And with that, I'd like to turn things over to our speaker, Julia Carter from Broadcom.
Thanks. Good morning, everyone, and thanks for joining us for this session on what's new with the CA Db2 tools. I'm Julia Carter, and I'm a Db2 technical consultant at Broadcom. I'm going to cover a handful of features from a few of the different tools which I hope you'll find interesting. Here's our standard disclaimer, although everything I'm talking about today is already generally available, so no juicy secrets for you, I'm afraid. Here's our agenda, and the first thing I'm going to talk about isn't actually that new, but I'm not sure how I managed 15 years as a DBA and I didn't know about using USS pipes to unload and load data. So here we'll have a look at how easy it is to do with fast unload and fast load. The second item will be a demo of our mainframe Team Center performance solution, which is our new web-based user interface to support some of our products, and we'll look at the performance element of that. So any Detector users will probably find that interesting. Then we're going to have a quick look at Test Data Manager and its integration with RC Extract, as I think test data management and compliance is quite a hot topic at the moment. And finally, how RC Migrator and RC Compare can be integrated into a DevOps pipeline with some recent developments in that area. Okay, so first up is using USS pipes with fast unload and fast load. The concept of pipes in Unix system services has been around since, well, a very long time apparently, but in all of my years working as a DBA and trying to figure out the best way to move data from one place to another in all sorts of situations, somehow this never came up. So although it's not new, it might not be something that you've come across yet. The traditional approach is to sequentially unload DB2 data into datasets and then load it from the datasets. It involves a large I/O overhead as the data has to be transferred through external storage, so DASD or potentially tape. Also, the load job has to wait until the unload job has completely finished before it may begin. A cross-loader process would also get around the need for external storage, but it can be fairly slow, particularly when dealing with larger data volumes. USS pipes can be used to unload and load DB2 data in parallel, which can decrease the overall elapsed time. When doing this, the data is transferred through internal storage without the external I/O involved and the overhead that comes with it. But the key point is that the unload and load processes are performed simultaneously. This process uses named pipes or first in, first out files in USS, which are a special file type in Unix, but are very simple to start using. The unload job opens a pipe or file and starts writing to a queue. And you would submit your load job at the same time, which would open the pipe for reading, and it would read off as the queue is filled. If you're unloading and loading between large partition by range table spaces, you could have one pipe per partition and get a really good degree of parallelism. There are two ways to create the pipe that we would then refer to in our unload and load jobs. You can go into Unix system services and do the make FIFO command as shown here, or perhaps the easier option is to do it with a DD statement in the Jcl. So here we have to provide the pipe file name. DSN type should be pipe. Then for pathops, the first in this example is ocreat, and that means that if the file does not exist, then the system will create it. However, the directory specified in the pipe file name must exist. If the pipe file does already exist, then with these options it will be reused. The second parameter there, OWR only, means that the program should open the file for writing only, so this would be used prior to unload. Path mode is where we specify the file access attribute. In this case, it is for the user ID who created the file and specified that they can read and write to the file. Path disp is straightforward. In this case, we are saying keep the pipe file whether the process ends normally or abnormally. Here is an example of the fast unload syntax when using pipes. The only difference you'll notice compared to a standard fast unload job is that the sysrec DDs have the pipe file name rather than a ZOS dataset name. You'll notice that here we are doing the unload at partition level and have a separate pipe for each partition. Similarly, the fast load step here, which you would probably want to submit at the same time as the fast unload job, this has a very familiar look too. Again, the only difference really is the pipe file names instead of a ZOS dataset name for the input. The other item highlighted here is the estimated input line, and it's important to try and be as accurate as possible with this when using pipes. If you were using a normal ZOS dataset, then we would do the estimation based on the dataset size, but it's not possible with pipes, so you do need to indicate how many rows you're expecting. So that's all there is to it. Very simple, but I think it could be very useful. Now we will have a look at a demo of the performance element of the Mainframe Team Center tool. This part of the tool is about Detector, but with an intuitive browser-based user interface. So let's now do the demo, starting on the login page for Mainframe Team Center. I enter just by using my normal mainframe credentials. So the security is exactly the same as if I was entering into Detector via the 3270. And once we're in, you can see that we've got two tabs, Administration, which is for RC Query, and in the future it will have functionality from RC Migrator and Compare, and so on. And the Performance tab, which is what we're going to look at today. And this is where we'll see Detector in a nice GUI. So first things first, I have to select the Db2 subsystem that I'm interested in. You can just type it if you prefer. And in our case, we have multiple X managers running, so I choose the one that's appropriate. But if you don't have multiple X managers, you wouldn't have that option. Next, we've got the performance category that we want to start by looking at. And you can see here all of the things that you'd normally expect to see in Detector: packages, plans, SQL statements, SQL codes, user IDs, and so on. I'm going to choose plans because that's what I would see if I went into Detector. So I just want to be able to compare like for like. Now, finally, on the right, we've got the interval range that we want to look at data for. So we can either choose the current interval or we can look at historical interval by just choosing the date and the time from this. Oops, 0. And for the end date, I'll just look at 1 hour's worth of data. And then I click on View Range. And we see the plan data for that particular hour interval. And the first thing you probably notice is that you can see a lot more than if we were looking in Detector natively. Normally I'd only have 8 columns worth of data in Detector, but here I've got 11. And I can easily change the size of columns. I can move them around just by dragging and dropping them. You can have this little arrow and just click to change the order that the data is sorted by. And also we've got this filter button for every column. So we can filter and say, let's just look at SQL greater than 100. And so we filtered, and I can add more filters to other columns as well. The other thing that we can do here is we can drag a column and freeze it. So if you're used to Detector, you'll know that there's an awful lot of data here, so many columns. But if there's a particular column that we always want to be able to look at when we're looking at the other data, we can drag it to the left of this grey line, and now it's frozen. And so it stays while we continue to browse, which I think is really helpful. The other thing that you can do here is you can look at the totals or average for the time, which is the same as you'd be able to do in Detector. And over here in Settings, we can save the table configuration. So if I'm changing the the order of the columns, and if I'm freezing columns, I can save that table configuration. I can also reset it if I've made some mistakes and want to go back to the default. I can disable or enable row caching, and I can choose how many rows I want to see in each table. So I've limited it to 100. This is a small environment, we wouldn't see more than that anyway, particularly for plants. The other good feature here is that we've got this button which will export the contents of your table here to a CSV file. So I can click on this and it gives us options. So I haven't currently got any rows selected. So it doesn't give me the option to export only the selected rows, but I can export the displayed rows, or I can just say all of them. I click on export and it gives me a CSV of what's currently on the table. So that's a neat feature too. Now we can start drilling down and looking in more detail at what the plans are doing. So if I click on this plan here and then choose actions, I can then look at the associated packages or the dynamic SQL statements for that plan. I'm going to look at the packages. And now I've got the packages and all of the associated columns for those. And now I can drill down further and click on a package that I'm interested in, and I can look at the SQL statements for that. And again, I can click on an SQL call that I want to look at, and I can see the SQL text. Now it gives it to me here in this format, and I can drag that quite a long way, but ideally I would like to be able to see it in a better format. So it gives it to me here, and I can now copy and paste this, and I can take it to an explain or whatever I want to do with it, but it just gives it to me in this better format. So I'm now going to look at SQL Codes. Now if I click on View Range again, oh, well, there weren't any. Let's have a look in the current interval. We've got some in the current interval. Okay, oh, quite a few actually. And probably the first thing you've noticed is that we've got these graphs. They might seem a bit excessive, but actually they've got quite a useful function. We can easily filter by clicking on one of these bars. So if I just want to see these -616 errors, or the 1 -616 error, I can just click on that and it filters for me. I can get rid of the graphs by clicking on this, and they reappear if I click again. If I just clear that filter, and we'll see them all again. So if I look at the -669s, again, we can see all of the errors for that and the information about them. And if I click on here and I click on actions, we can look at the SQL code details. And this gives us, in a really easy to read format, what was trying to be done and why it failed. So again, really easy to look at and to understand. And you may have noticed that along the top here, we're starting to build these tabs. And I can go back to a tab, and there's the data that I was looking at before. And I can just flip back to SQL codes now. So that's really useful as well. So you're not constantly having to go back and re-look at things if you need to. So those are the main features of the Mainframe Team Center performance tool. Now we'll move on to talk about Test Data Manager and its integration with RC Extract. This integration has come about as part of our work to help customers with their data governance and compliance. Everyone listening will be familiar with the latest legislation regarding the use and protection of data, and all of our companies are having to find smarter ways to ensure our compliance and to protect ourselves and our customers. With such a huge amount of corporate data being stored on the mainframe and the cost of a breach being astronomically high, companies are looking for ways to ensure that they are not only conforming to the directives, but also to mitigate the risk of data breaches. To optimize the quality of testing, it's often not possible to use manufactured or randomly generated data. We're likely to need data that has the same structure and volume as our production environments have, or we expect them to have. But we can't simply copy the production data to a test environment, as this is likely to expose some sensitive and personal data items. And we all know this hasn't been acceptable for years, but now regulations are much stricter and non-compliance will be very costly. Our solution addresses these problems and risks by integrating Test Data Manager with its masking capabilities into RC Extract. RC Extract will call TDM to do the data masking using an API, and the source data is masked during the extract process. The data written to the extract file will be masked. TDM provides intelligent data masking capabilities whilst keeping the logical meaning. Test Data Manager was acquired a few years ago by CA from Grid Tools, so you might have heard of that name before. Its main feature is being able to mask data whilst ensuring it is still usable. So a postcode would be changed to another valid postcode. National insurance or social security numbers or credit cards would follow the correct format and any rules that apply to them. This is all completely customizable by the user for one or for some or for all columns in a table. We have approximately 100 profiles that are provided out of the box with TDM for masking, and users can even create their own if they have specific requirements. Simply scrambling the values or using unintelligent masking could cause the application to fail, or at least give potentially unexpected or maybe unpredictable results. TDM, or Test Data Manager, can actually be used for any RDBMS or file type, but there's a subcomponent called MDM, or Mainframe Data Manager, which is a portion that has now been integrated with RC Extract. So now a quick look at RC Extract, which has been part of the CA Db2 Tools portfolio for many years. It's really useful because it can extract referentially intact sets of data. We give it a starting table and it will extract child relationships, plus any other parents and children that are related to those children. If there is system-defined RI, then it can work from that, or a user can define their own relationships in the RI manager, which can also be used. When used natively, the extraction can be done either online or in batch, and there are various options for the method that the data is extracted, by SQL or using the CA Fast Unload utility or the IBM Unload utility. RC Extract can also perform some data masking or scrambling itself, but it isn't as sophisticated as TDM's masking capability. And now we'll look at the architecture diagram of the TDM and RC Extract integration. The top half of this slide is showing the data maker in TDM, which is the engine, and the rules map is being output from there. With the integration with RC Extract, this still happens, but that map CSV file is transferred to the mainframe, and at that point we move to the bottom half of the picture. If masking is requested, then RC Extract takes the mapping file and enhances it by propagating the rules to all of the related columns. Then it gives the control to the TDM API, and the data is extracted via a batch SQL process, and the data is masked as it's extracted. So, as I said, it never sits unmasked in datasets on the mainframe. RC Extract is available from the main CA Tools menu. It's option 5. We then choose option 1 to define the extract and the load options. It's a very simple 4-step process. You just follow the steps to extract, to mask, and then to load the data into the target. This screen in RC Extract has been updated with the new field for the map CSV file. We provide the starting table, in this case ACT. By typing cell all on the command line, it brings in the referentially related tables, so proj and proj ACT. This is an example of a map CSV dataset, which would have been generated in Test Data Manager and FTP to the mainframe. It shows the tables and the columns of those tables that should be masked and with which masking function. So we can see on the second line, well, the first line is the column headings. So the table name, the column name that we want to be masked, the function that we want to mask it by, and then some other parameters. So looking now at the second line that starts with act. Act is the table name, act no is the column, and the function that we want to perform on that column is we want to add a random number between 10,000 and 20,000. If we look at another example in the project table, for the project name field or column, we want to change it to an email address. So now we'll have a look and see how this turns out. This is an example of the data before we do the masking on the ACT table. As per the map CSV rules, the function was to add a random number between 10,000 and 20,000 to the ACT no columns value. And here they are next to each other, so it's quite easy to see the act no column before and after the masking has been done. And now looking at the project table, we need to look for the project name, the PR staff and the PR start date changing on the next slide. So it's added 10 days to the project start date, it's added 50 to the staff number, and it's changed the project name to an email address. To summarise what the integration gives us, Mainframe Data Manager and RC Extract together provide a faster and a more flexible mechanism for extracting referentially intact data on Db2 for ZOS, with large volumes and with superior data masking, which helps us to conform with the various data protection laws and regulations. If you'd like to know more about the tools that you need in order to do this, please let me know. And finally, a recent enhancement in RC Migrator and RC Compare is that we provide some of the building blocks to help you to build your own DevOps pipeline and incorporate Db2 schema management. We have a set of Jcl templates, a sample DevOps Jcl workflow with Jcl and procs derived from the templates. And we have documentation that describes how you can use Jcl and open source DevOps tools like Zoe or Jenkins to help you to build your own workflow. Here are 4 Jcl templates that are now available and were delivered via a PTF a couple of months ago. We're looking at the name of the template and its purpose, which CA product it uses, and the input and output for each Jcl template. The first is to simply generate DDL from a source subsystem and produce a DDL file or dataset. The second performs a syntax check of the amended DDL. For this, a DDL file or dataset is passed in, and the output is either the same DDL file if the syntax is all correct, or a report of the invalid DDL. The third is a 3-step process to create a batch processor script by creating an RC compare strategy, then analyzing it and generating an ICL or incremental change language report, and a batch processor script as output. Finally, the 4th template executes the batch processor script to make the changes to the target environment. Depending on the particular task, you would use a different combination of these jobs, which we'll look at shortly. But first, let's have a quick look at an example of one of these templates. It's a normal batch version of a job that invokes RC Migrator and then generates DDL with the DDL only option. The objects that are to be included are specified in the parameter file input for a quick migrate type of migration. There are standard Jcl variables prefixed with an ampersand, and some of them are substituted into the in-stream parameter file and read by RC Migrator. Then there are Apache velocity compatible variables, which are prefixed with the $sign. Finally, we have template engine syntax statements, which are prefixed with the hash symbol. When using the templates as JCL models, the template engine syntax is replaced with appropriate values. Here are some examples from a DevOps workflow that could utilize these JCL templates. We're assuming here that there are three environments: a development environment, a test or CA environment, and lastly, the production or live environment. If you initially needed to provision a dev environment with DB2 objects from production, you would use rmatm001, 003, and 004. If you wanted to amend and test object changes in that dev environment, you would use rmatm002, 3, and 4. If you wanted to promote changes from development to a test or QA environment, you would use rmatm001, 3, and 4. Then, after performing some testing, you would go ahead and promote the DB2 changes into the production environment using rmat001, 3, and 4. It's at this point that a DBA can be notified to give final approval before the change is promoted to production. In addition to the 4 JCL templates, we have 3 additional samples for promoting DB2 objects from a source environment to a target environment. And this combines what we've just been looking at to provide a simpler and more streamlined approach to a DevOps pipeline while sticking to processes being managed on the mainframe. First, we have a proc, RMA prom P, which is another multi-step process to generate DDL for selected objects, then compares the DDL to the objects of the target environment by creating and analyzing a strategy and producing ICL and the batch processor update script, which will eventually make the changes to make the target look like the source. The JCL RMA prom J invokes the RMA prom P procedure, and the RMA prom X job executes the batch processor script that's been created by the proc. Now let's look more closely at the sample proc. First, this is the RMA prom J job, which invokes the prom P procedure and passes the names of the source and target subsystem, as well as the submitter's email address for notifications. The only other input needed is the object specification selection, which are the objects that are to be processed. Only the database needs to be included because the proc has been pre-configured to include all related and dependent objects. The RMA prom P proc has a set of one-time configuration parameters, which is where you can include the mailbox or distribution list for the approvers. And as well as those, it captures values supplied by the RMA prom J job. The object list is also passed in from the job to the proc, and the batch processor script is then generated. Once the RMA prom J job has completed, the DBA can review the changes and approve them, and in doing so, the RMA prom X job is submitted. This executes the batch processor script and actually makes the changes. And the prom X job includes recovery or a backup script should you need it. I'll now summarize the main steps of the RMA prom P proc, assuming each step completes successfully. The proc initially copies the object selection to a temporary file. Then it generates a DDL for those objects. Then it creates a compare strategy using the DDL as the source and comparing it with the target subsystem. Then the compare strategy is analyzed to create the batch processor script, and an ICL report is generated. And finally, an email is sent requesting approval, including the update script and the ICL report for review. Let's now take a quick look at the email that is sent by RMA prom J to the approver, informing them about the request for DB2 changes. It allows the DBA to review and approve or reject the changes. The batch processor script and ICL report are attached to make it easy, but of course everything can be reviewed on the mainframe if preferred. If the approver is manually submitting the RMA prom X job to implement these changes, the parameters are provided which need to be used. We've also got some snippets of the ICL report on the right-hand side of the slide, which demonstrates the changes that will be made, but without any of the utility steps. So it makes it very easy to see and understand the changes. The batch processor script contains the full DDL that will be executed, as well as any utility steps that are necessary. If the request is approved, then the simple RMA prom X job is submitted to apply the changes. Upon successful completion, the results are emailed to both the approver and the submitter. The execution log report or job output, plus the recovery or backout script are attached. At this point, if the job is finished successfully, then it means that the objects have been promoted or deployed to the target environment. While the Jcl templates and Jcl and proc samples can be used natively by mainframe developers and DBAs, we can take it a step further and make Db2 just another database. And I'm saying that in quotes because we all know that Db2 isn't like any other. But anyway, this can all be integrated in a modern DevOps pipeline, maybe one that's already in use for other databases or for other types of application changes. There are countless technologies and solutions in the world of continuous integration and continuous development. And your DevOps engineers are likely to have their own preferences, and you may have organizational requirements or standards that you need to follow in that regard too. So keeping all of that in mind, our solution is built to use your technology stack of choice. And there's an example on the screen, but it can be almost anything you want it to be. The functionality provided by the Jcl templates that we looked at first can easily be incorporated into a build script to completely hide the 3270 elements of the end-to-end schema change process. Things can be made as simple or as complex as you like or need. The basic script task logic can be split into these 4 steps. Take the template configuration values, customize a Jcl template using the configuration values, submit the customized template to the mainframe, and retrieve the job output. The Jcl templates that we've discussed can be stored securely on the mainframe, but they could also be copied to a source control system like Git, along with the application code, so the developer would never need to leave their IDE. In addition to the templates, you can store the DDL or the .sql files in Git too. Configuration values for multiple templates can be stored in a single JSON file and also maintained in the source version control system, so they are easily accessible and reusable. Here you can see the configuration like the job card, the dataset names to use, Db2 libraries, and RC migrator inputs like the model name and the creator. Here we see a basic Ide pipeline example. The first step to configure the environments, the template substitutions, change sets and credentials, and to execute the DDL gen script, which is essentially the rmat m001 DDL generate job that we discussed initially. Then changes are made to the DDL in the .sql file, and scripts are executed to check the syntax, which is like rmat m002. Then compare the source with the target, or rmat m003, and deploy the changes, which is like rmat m004. In this case, it's a bit difficult to see the result, but it's a new column that's being added to an existing table. And if we bring Jenkins into the mix, we can do the first 2 steps as per the Ide pipeline, still using those templates, but then we can create a pull request to get DBA approval. And once approved, the Jenkins pipeline is triggered and the changes are made to the system. So we've seen 2 fairly different ways of using the Jcl templates and sample jobs and proc that are now available with CA RC Migrator in a DevOps pipeline. Those were the things I wanted to share with you today. Please go ahead and ask any questions you may have now, or feel free to email me if you'd like any more information about any of these topics, or indeed anything to do with the CA Db2 tools. So with that, thank you very much for listening, and I'll hand you back to Niall.